Very good afternoon, everyone.
Hi. Hi, everyone. A very warm good afternoon to everyone. We are giving people a couple of seconds for them to join the call. Those who have registered, those who want to join the webinar, you can ask your friends to join. You can ask your acquaintances or anyone you know would benefit from the webinar to join this particular topic and particular webinar where we would allow a couple of seconds, maybe 1 or 2 minutes, for people to join in before we begin our webinar on the topic: a beginner's guide to Internet of Things, technologies, careers, and future skills. And those of you who are joining in and trickling into the webinar, thank you so much for joining in. This shows that you are interested in the topic, and this motivates us to present us new topic and to bring you new topics into new emerging technologies to you time and again. Good afternoon, Balaji. I can see messages trickling in from people. So this will be the flow of the webinar. Aditya will take you through the topic. Aditya Johar is the speaker for our today's session, and then we'll open the house for questions from all of you about your career and what you can do, what skills you have to learn. All of such questions and frequently asked questions that you have in your mind will open the house for that, and then we'll take you through the platform from where you can learn all these emerging technologies, including IoT, and then we'll close it. It will be a 60 minutes ride that we'll take together. I can see that we have been joined by a few people, and without wasting much time, let's start on it. Hi everyone, this is Hina Kausar, and I will be a moderator for this session. I am Deputy Manager with NASCOM. Thank you so much for taking the time to join us today. We are happy to have learners who are interested in learning this topic. Internet of Things is confounding to a lot of us, including me. I'm a layman. I don't understand the nitty-gritties of Internet of Things, but we do understand that the technology is transforming the way that we work, we live, we connect with each other and the world in general. We also understand that it's being used in healthcare, in intelligent manufacturing, in wearable tech. IoT is everywhere that we see, but we do not understand the nitty gritties of. But also, we have a doubt in our minds as to how do we break into this field, what roles exist, what skills are in demand. Uh, that's exactly what we will unpack today. It's my absolute pleasure and honor to introduce our esteemed speaker for today, Mr. Aditya Johar. Aditya is currently with OrangeMantra, where he leads innovations at the intersection of AI, ML, and IoT. With over 10 years of experience in emerging technologies, Aditya has built solutions and applications that power smart devices, intelligent automation, and connected ecosystems. Previously, Aditya has worked with Effectual IT Solutions, where he led end-to-end development of several high impact IoT products. Without further ado, I would like to hand over the stage to Aditya. Welcome, Aditya, and thank you so much for being here with us.
Thank you. Thanks so much, Ina. A very warm welcome to everyone who's joined in. And this is going to be an interesting session, the Internet of Things. And this is really, when I started with the Internet of Things, it was more of a passion project. This is about 8-10 years ago, working with small chipsets like Raspberry Pis and Arduinos that were just getting popular around 2014, 2015. So coming from that 10 years ago, where we started and where we are today, I think it's become a leapfrog of technology, where we started and where we are today. So I'm going to take us through the the key changes and the key updates and where the industry stands today and why IoT is going to boom even further in the next 5 to 10 years. The wave has just begun and it's just going to boom further. So let us learn a little bit about IoT. Let us learn what it's all about and how we can have a career in this and build fruitful and valuable technological solutions. So speaking about IoT, what really is IoT? So IoT is like it definitely is a rapidly growing industry in today's time. However, IoT is essentially it stands for Internet of Things. And what does Internet of Things mean? Internet of Things simply means all the daily devices that you see in your life, whether it would be a light bulb, an air conditioner, uh, your vehicle, your bike, your maybe a door, maybe a warehouse, maybe a refrigerator. Everything is connect, connected in today's world to a certain extent. Now, when we say that these things, these immobile, inanimate objects, they are suddenly now connected, what does that make them? It makes them the Internet of Things. All of these devices now, whether we say, with very popular in today's time, we have smart homes, smart factories, smart warehouses, smart restaurants. You go into a restaurant now in McDonald's, you can place your order digitally. You don't need to stand in line. I mean, there's an option definitely available. So the internet has made this possible. And bringing connectivity to small devices, to these small things, and allowing them to communicate with a data center or a cloud or even your mobile phone, this brings a next level of communication that was not possible before. How? What happens is, let's say you had a warehouse. Let's say you were running a warehouse, a cold storage unit, and you needed to make sure that the cold storage unit stays at 2 degrees Celsius all throughout the unit. It might be easy if you define that, okay, air conditioner, let me make it as cold as possible. Let me keep it at 2 degrees and hope that the entire unit stays that cold. Now, in that scenario, you are going to use a lot of power for your air conditioner to make sure that ensure that every part of that cold storage unit stays at 2 degrees. But when you trace back and you realize that when you've got such a big unit and maybe certain parts of the unit are going to stay at 2 degrees regardless of whether you power up the AC or power down. And other parts of the warehouse or of the cold storage unit actually will get warmer and will require more energy to come down to 2 degrees. Now, if a manual person, if a person has to go into that entire warehouse, let's say it's as big as 100,000 square feet. If a person has to go around and check the temperature at each corner and make sure that every corner of that warehouse is at 2 degrees, I think it's going to take a lot of effort. It's going to take a lot of time for that one person to be able to manually check these temperature points in that warehouse. This is where a key example of Internet of Things comes in. You set up a few sensors around the warehouse. You allow them to pick up the temperature, typical standard temperature sensor that costs 100 rupees each. You set them up at maybe 20 locations in the warehouse, allow them to monitor the temperature and send that data to the cloud so that, again, your air conditioner, which is also an internet connected device, gets the information from each of those sensors and accordingly adjusts. If the temperature is, let's say, 1 degree Celsius, that means you're using more power than you really should. You need to keep it at 2. So how can you save money? That sensor is giving you real-time information of each location inside that warehouse, and it is allowing you to know that this is the temperature at this part of the warehouse. I need to make sure my air conditioner is giving this temperature at that part itself. Companies have seen reduction in cost of up to 50% when they have gone and they have implemented Internet of Things technologies in their factories, warehouses, even vehicles. We'll look at vehicles shortly as well. Motorcycles, batteries, boats, aeroplanes, smart cities that are hospitals. All of these different industries and different segments have seen major cost reduction when automation and Internet of Things have come into the picture. Now, why has there been a boom in Internet of Things? First, let's take a look at how much the industry has grown in the past, just the past 3 to 4 years. So if we look at, um, there's some noise from the background. Can we please go on mute, everyone? Yeah, thank you. So if we look at the global industry of Internet of Things, how much has this market grown? Look at it in 2023, it was a $212 billion market. Today, it is at 273. If I look at what the market was in 2018, in 2018, the market was just $100 billion. It has gone almost 2.5 times in a span of 7 years. And by 2033, this is liable and it is going to go up to 700 plus billion dollars. Why? Firstly, there are several reasons. One of the key reasons is the advent of high speed internet across the world. With high speed internet across the world and wireless internet, not wired internet, with a SIM card now, you're able to get high speed internet at even the most remote corners in India or even globally. This allows for small devices to have a SIM card inside and be connected with the internet and send data that previously, maybe 5, 7, 8 years ago, was really expensive to send. So, one, advent of high speed internet has brought costs greatly down. Second, the cost of the sensors themselves have also really come down, which allows for a mass adoption, which allows for a mass market to adopt these sensors and leverage the full benefits that they provide. The third part of it is, which actually has combined all these two things together, is that technology has also advanced and the people have gained an understanding of how to utilize this technology. So earlier, if there were only small companies that were really leveraging IoT systems, maybe let's say there was an IBM or a Motorola or a Siemens or a Cisco. In today's time, now most companies understand what IoT does. It has become prevalent and it has become ubiquitous to a certain extent. So this market is now huge, and globally it's only going to grow because the demand, the cost of sensors and cost of internet is going to keep coming down, and the requirement for technology to keep up is going to increase. So it's a very viable and a very valuable market to be a part of. It's going to grow at 10% plus every year. Now, what are the use cases of IoT? Let's take a look at how much the market has grown, absolutely. But let's also take a look at what are the key use cases. If you see in 2021, process automation in a factory, all the processes that you've got, you might have some inventory management solutions. Previously, maybe the inventory count would have to be done manually by a person. That how many, let's take for an example, how many packets of biscuit have been created by the machine and exited at the endpoint. A person might manually count it. Now, with the advent of infrared sensors, you can easily count that, okay, it's automatically giving you a real-time count that today we've got 1 million packets of biscuits or we've got 100,000 packets of biscuits released. This kind of process automation has become really prevalent in the past 5 to 10 years. Looking at this process automation, if you look at 33% was the adoption in 2021. Today, process automation in typical factories has gone up to 58%. So the outlook is looking even much more beyond. I mean, if 58% has adopted this process automation, there's still a scope of 42% more companies that have not adopted. There's a market to be tapped. Quality control and management with IoT systems, computer vision, robotic vision, you can, and not only that, even automated weight mechanisms, weight checkers, shape checkers. You can check if the quality of the product that is being produced, that could be a gear, that could be a lever, that could be a screw, that could be uh, it could even be a hammer, it could even be a screwdriver. The quality of the part that is being produced can be checked in an automated fashion. Look at the adoption. In 2021, it was 30%. Today, it's 55%. Energy monitoring. This is extremely important. The first example that I gave you, where the warehouse, a large warehouse, 100,000 square feet, it's impossible to monitor the temperature every hour manually. Nobody can do it. I mean, it's not viable. In India, maybe, where manpower and labor is easily available, it might be happening in some factories, but in other places like the US and Europe, where manpower is just not available, these kind of processes don't happen. Nobody is there to manually check temperature and all these conditions, humidity, pressure, air pressure. All of these processes are automated, and these are significantly bringing down energy utilization costs for companies. Here, the adoption has been even more rapid, 20% to 55%. Because the sensors are available, they are easy to set up, they are easy to apply, and companies are leveraging the full benefits and saving costs. Inventory management, like I told you, the uh, let's count the number of packets of biscuits that are produced in a day, or supply chain track and trace. How many boxes came in? Where is a particular unit of inventory sitting in a factory? Can I use RFID to track that? Do I know which box is being exited from my factory and coming into my factory in an automated fashion? Earlier, maybe a person would have to manually write down a lot number or a barcode number or a inventory number on an Excel sheet or maybe a piece of paper. Now that entire process can be automated. Operations planning and scheduling, leveraging IoT to monitor how many people are required at a particular security checkpoint or a gate, facility track and trace. All of these, if you see the amount of growth that has happened in the past 3 years, is phenomenal. There is double-digit growth happening, and this is only going to happen even more. The market is so untapped for IoT systems that this is a field that is going to boom for the next 10 years. However, there are certain things we must keep in mind when we look at fields booming. That means that technology is also maturing, and the requirement of the customer is also maturing. They are not long gone are the days where the basic product would work. They are looking for advanced solutions to advanced problems. So if we take an example of what is a modern factory, what's happening in today's time in a modern factory. About 5 years ago, the same image would be that this is going to be a future factory. But in 5 years, the entire market has changed so much that now a modern factory, it looks like this. If you go to any modern manufacturing unit, you would see that they have computer vision, they have cobots, collaborative robots, they have unmanned trucks inside their units, they have unmanned forklifts, they have unmanned robots circling around the factory, picking up a product from one side to another. They have IoT sensors for their supply chain, like I mentioned, count the number of biscuits, for example, that are being packets that are being produced in a day. Augmented reality is helping workers understand better what the in high engineering and high precision manufacturing environments. They have augmented reality that's helping them create better products. All of this now is a reality. This is happening now. The time where this was future, that robots will be manufacturing a particular part or a particular good, it's not the future anymore. This is now, it's happening. So understanding how this is happening, because at the end of the day, it's not magic. It's not it's not something that's out of this world. This is something that has been engineered by humans, built for humans by humans. And understanding how this is happening is going to be a great benefit in the long run, especially for those who are just starting their career right now. This is a great time for you to learn these technologies and learn how all these things are happening. So you build a strong base and you're able to deliver upon this base in the years to come. So, what does it take to become an IoT expert? So, one is definitely it requires a lot of passion. The reason it requires a lot of passion is IoT development is it can involve long hours, long trials, testing, quality analysis, troubleshooting. So you need to be really passionate about this entire industry. And if you're passionate about this industry, you will definitely do whatever it takes to become good at it. Having said that, technical knowledge, having a good technical base is very important. By technical base, I mean, of course, what you learn in school, mathematics, physics, science, all these things are important. These build a strong base. These help you to take your knowledge to the next level so that you are able to apply it better. Now, when I say what are those one, two, or three things that you require to become an IoT expert? One, you need to understand today that everything is cloud based. There is a requirement for all technologies to be cloud first. So, understanding the current technological landscape, that is very important. What I used to use 10 years ago to develop some product or a solution is not really relevant today. If websites were built in pure HTML 10 years ago, today maybe they are not. They are built in frameworks such as React and Angular. That's an example for a website. If cloud solutions, earlier servers, companies used to have server rooms so that they could serve their websites and web applications and mobile applications. Today, they don't have server rooms. Everything is hosted on the cloud. They use the cloud, they serve the applications from the cloud. So understanding what is the current market landscape, that is extremely important. You have to keep up with the times. And third, you need to not just have theoretical knowledge. I mean, theoretical knowledge can only help you get 10% through the way. It's not going to help you, uh, become very successful at it unless you don't have any practical hands-on skills. So one, you need to have passion for Internet of Things. You need to have passion for robotics, for microcontrollers, microprocessors, sensors. You need to have passion for just seeing these things in action. You need to be able to go into the depths to find solutions. And you need to have a strong technical base that can help you achieve these things. But make sure you have practical knowledge, otherwise, that knowledge is of no use. Some of the core fundamentals that involve all IoT systems, they typically encircle around two facets. One of the facets is microcontrollers, and the other facets is microprocessors. Microcontrollers are typically, if you know what an Arduino is, or if you know, for example, what microcontrollers do, they interface with the sensors to provide the sensor and pick up data from the sensor and send information back to the sensor. So let's say you would have a temperature sensor that's sitting at that warehouse. It would be connected to a microcontroller where that sensor would be sending the data to the microcontroller. And then that microcontroller would be sending that data to the cloud or locally. For example, if the database is available locally itself. The microprocessors, they are for, let's say you have 8 microcontrollers and you want to have all of that data going into a central location. You would use a microprocessor for that. So a microprocessor is, let's say it's basically a computer on a chip. That's what a microprocessor is. A microcontroller is the interface that a sensor utilizes to connect and send and transmit data. So there's microprocessor, then there's the microcontroller, and then there's the sensor. Now, there are instances where the sensor connects to the microcontroller and the microcontroller doesn't connect to a microprocessor, but instead connects directly to the cloud. But these situations are, on a case by case basis. You need to analyze the entire setup and system where you are deploying your application to understand that would you need a microprocessor or will a microcontroller just do? In the next couple of slides, I'll be showing you what exactly these are to paint, a visual picture. And some of you may have already worked on a lot of microprocessors and microcontrollers. So here, what we've got, the two most popular microprocessor and microcontroller basically are for a microprocessor, it's the Raspberry Pi. For the microcontroller, it's an Arduino. Now, of course, even the Raspberry Pi has the Pi Zero, which performs the function of a microcontroller. But let's look at the history of the Raspberry Pi. This is the most commonly used microprocessor in the world. This came out in the early 2010s. It came out first around 2012, 2013. And ever since then, it has become the go-to device to connect IoT systems all together, to bring an entire IoT network together. Why? Because if you look at it, it's just a small chip. The chip is actually the size of your palm. It's in some cases even smaller than that. They have many variants. There's a Raspberry Pi now, the fifth Raspberry Pi 5 has come out, just like you've got iPhone, 11, 12, 13, 14. Now we've got Raspberry Pi 5. And there are variants in that Raspberry Pi 5, which you have the 8 GB RAM, you have 4 GB RAM, you have 2 GB RAM. So depending on what you're looking for, you have a Raspberry Pi available for your entire use case. Having said that, the Raspberry Pi is a very beautiful. It's a Linux-based device, and the OS of it, is a very beautiful setup. The reason being that you have so many variants and so many different things that you can do with it. You could connect you could literally connect a keyboard and a desktop and monitor to it, and it becomes a computer. You could literally have a Linux-based computer based out of that chip. You could connect your a 3D projector to it, or you could connect uh, or you could connect your HDMI cable and watch a movie on via the Raspberry Pi. So the Raspberry Pi, it costs around 4,000, 3 to 4,000. The 2 GB version costs around 4,000, and then the 8 GB one goes up to about 6,000, 7,000. The chip itself. So they are economically priced, highly useful, highly powerful, and they have a wide variety of use cases. If you see where I am pointing with my mouse right now, those pins that are coming out, those pins essentially help you to connect the Raspberry Pi to sensors, to edge peripheral devices. And if you see here, you've got an HDMI slot. If you see here, you've got an audio interface. If you see here, you've got the Ethernet jack. So the Raspberry Pi is a very beautiful device. It's a microprocessor, a high-powered computer that can connect to a multitude of sensors. Conversely, a microprocessor typically connects, it doesn't have as much of a compute power as a microprocessor would. By that, I mean it doesn't have as much compute power in the sense that it doesn't have 8 GB of RAM or 2 GB of RAM. These typically have just 512 kilobytes or maybe 1 MB of space of processing power. But the difference is that because they are so lightweight in nature, they connect to the sensor and are able to send and receive data really fast, because that's the only job they do. They don't have any other job. A Raspberry Pi is a complete computer on chip. So you need to understand both the use cases and see which one fits best for your requirements. Here are some sample sensors. You've got proximity sensor that it measures the distance between one point to another, a vibration sensor. Then you've got the heartbeat sensor, water level sensor, alcohol sensor, soil moisture sensor, accelerometer. There are different kinds of sensors that are available that help you. These are the what you have that connect at the edge. If you have the warehouse, you would connect 20 of those temperature sensors at the different points of the warehouse. And temperature sensors also have hundreds of different kinds. For example, you might have a temperature sensor that works only between 20 to 40 degrees of temperature. You might have another one that works between -20 till 200 degrees. You might have another one that works at 500 degrees. Depending on the use case, you would have different kinds of sensors. So a water level sensor, if you have a water level sensor that works, you might have one that works in water. You might have another one that works in oil as well. You might have another one that works in turbid environments. So there are hundreds of different kinds of sensors as well, and you need to analyze the use case that you want for your particular sensor to define which one you need to utilize. Now, these sensors typically, if you look at this vibration sensor, this is a very standard vibration sensor, really cheap one that costs only about 150 rupees each. These three pins you've got, these are the pins. If you see the touch sensor, it's got these three pins. If you see these alcohol and gas sensor, it's got these three pins. So all these pins essentially are what connect to the microprocessor or the microcontroller via the wiring. So each of them have their defined protocols on how to connect, but these are the pins that interface the sensor between the microprocessor or the microcontroller. So how do you select the right type of sensor? You have to define what is the environment your sensor is going to be utilized in, what kind of communication protocol it requires. Is it going to have Wi-Fi, or is it going to have 4G, or is it going to be connected wired, or is it going to use LoRaWAN? You need to understand which environment and use case your sensor is being utilized for you to be able to uh, define which sensor you need. And the same sensor, you might have a temperature sensor that costs only 100 rupees, but there are temperature sensors that cost 50,000 rupees as well, depending on their environment. The temperature sensor that works at 1000 degrees Celsius costs a lot of money because it is made of that material, which is really pricey. So you need to understand what is the environment you're going to deploy that sensor in, so that you can plan for which sensor you need to utilize. Here is a sample architecture typically. So when you have these devices, essentially you can consider that a sensor, let's say a camera sensor is one of your sensors. A pressure sensor is another of your sensors, or a robotic arm is another of your edge device. That sensor typically connects to what you call an IoT gateway. So in most cases, an IoT gateway is a microprocessor because it has 2 GB, 4 GB, 8 GB, 16 GB, 32 GB of RAM. It can connect to hundreds of devices at the same time. It is the centralized place where the sensors connect to the gateways. And the gateway then collects the data from the sensors, sends it either to the cloud, or takes a decision that what needs to be done. For example, the gateway is connected to a temperature sensor in that warehouse, the first warehouse that I was telling you about. The same gateway will also be connected to the air conditioning. Now, when the sensor is sending it that data that now the temperature has reached 1.5 degrees, the gateway will then decide that, okay, the temperature has gone down by 1.5 degrees. So uh, let's turn the AC temperature up because the temperature has come down in that area and we don't need it to be 1.5 degrees. We can save energy. So the gateway will then send the command to the air conditioner, and the air conditioner will then increase the temperature slightly. When the temperature goes beyond 2 degrees again, let's say it goes to 3 degrees, the gateway will then send the command again to the air conditioner and it will say that bring the temperature down again. So here everything is happening real time. There is no need for manual intervention. The gateway is the brain that takes the decisions, and the gateway is also the brain that sends the data to the cloud. So let's say if the building owner or the building manager later wants to see that what was the temperature or what was the pressure or the humidity last week or 2 weeks ago or a month ago, so the data is available in the cloud and the data center is holding the data. So typically the architecture involves your device, which could be your sensors, air conditioner, could be your truck with GPS location. It could be a robotic arm, which is telling you what is the weight of the object it is picking up. It could be anything. The device connects to the gateway, which could be a microprocessor like a Raspberry Pi, and the gateway then connects to the cloud and sends the data. So this is the typical architecture. In most cases, the devices would be connected to a microcontroller, where the sensor is connected to an Arduino or another microcontroller, for example. And one more important point to remember is that the communication protocols for the gateway, they have to be lightweight. You cannot have heavy communication between the sensors and the gateways, because the sensors themselves, they are very low powered devices, in the sense that they don't have 16 gigabyte of RAM. They have just a few kbs. So that needs to be ensured that the communication is lightweight, and there are some protocols that are called MQTT, Zigbee. These protocols, especially MQTT, is highly used across the industry for lightweight communication between edge sensors and the gateways, and even the gateways and the cloud, because the communication is lightweight. Now, what are the different industries where IoT is really taking place? So you may have read about these, you may have uh, learned about these. You've got smart cities, water management, waste management, healthcare. Now your iPhone, Apple Watch, it's got your heart rate monitor and the blood pressure monitor and all of these things. What is this? It's nothing but IoT. Then you've got uh, transportation, traffic management. If some of you are living in Delhi NCR, you would have read about how AI cameras are regulating the traffic in the new Dwarka Expressway. So they've installed AI cameras at each of the signals, and based on the amount of cars that are there at each of the signals, they are now defining what how long the red light should be, how long the green light should be. So it is all happening automated. Those days where the traffic policeman would stand and then give the signals, it's come a long way now. AI cameras are taking those decisions. Your home appliances, your smart AC, which is connected with your mobile phone, you can turn the AC on before you reach home to make your house cool before you get there via a smartphone app. You can turn the washing machine on or off. You can change the mode on the washing machine with your smartphone. That's also IoT. Energy management, we've discussed this couple of examples, the warehouse, and then the temperature management. Then you've got smart manufacturing, lots and lots of sensors being used in manufacturing. Automotive cars today, your cars have telematic systems inside them that uh, allow them to make decisions on fuel consumption. Nowadays, cars can define, they have software inbuilt that takes a look at whether you are in traffic or you're driving down a highway, and accordingly it makes the vehicle fuel consumption in of different modes. So all of these industries, I don't think there's any particular industry that's left behind that is not using sensors and automation today. So it's really happening, and this is really the this is where the industry has moved, and a lot has changed in just 5 years. Now, with the advent of even more intelligent AI and machine learning models, it's going to even take further a deep dive in the next 5 years. It's going to really zoom. It's going to really boom. So, gaining expertise in this industry is going to be very valuable. How would you get started with IoT? So, of course, build strong fundamentals in electronics, networking, programming to understand sensors. It's very important not just to understand your microprocessors and sensors like Raspberry Pis and your sensors and or Arduinos, but also to understand communication protocols like how do you deal with load network situations or when network is gone. How can you make sure the communication is lightweight, using MQTT kind of protocols. Then also to understand cloud infrastructure, how cloud infrastructure can be leveraged to build robust applications. So to understand end to end is very important. If you understand only one piece of the puzzle, you may not be able to go very far, because each piece of the puzzle is linked to each other. So just understanding how a Raspberry Pi works, or how Arduino works, or how a temperature or pressure sensor works is not sufficient. Understanding cloud today is very important, because more and more applications, almost all applications now have moved to the cloud, and it's the most cost efficient and optimized way to serve a network based application. Plus, gaining hands on experience is very important. Without hands on experience, none of it matters. Uh, just getting a certification in IoT, or just going through an online course, or just going through some videos online is not sufficient. You have to actually sit there, connect the wires together, understand how everything is working, try it out, see the different scenarios that come up. What happens when you take, let's say, a pressure sensor from one part of the room to another? Or when the temperature increases, does the pressure sensor work as well? Does it not? Understanding edge cases, understanding edge scenarios, these are very important. So I would say learning the cloud, learning or how the entire ecosystem works together, and having that entire system come together is very important with hands-on experience. This is how you would get started. And then if you're very passionate about it, one thing will lead to another and you'll keep getting better. So there are careers in IoT today. There are many different kind of careers. The One of the senior positions is the IoT architect, somebody who understands the entire end-to-end system. I'm not saying that just the IoT developer does not understand the system, but there are some things that you learn mainly with experience as you work more in the field and as you go through more of the details and you gain more experience. That's how the IoT developer comes into the fray and becomes an IoT architect. Then there is the IoT data scientist. So data is another very, let's say you have 50,000 sensors. Let's say it's, all the trains in India are connected by sensors. How do you manage this huge amount of data coming every 5 seconds or 2 seconds or 10 seconds into the cloud? How do you manage this huge amount of data? Those are the IoT data scientists. They understand uh, databases, how to index shard databases, how to use real-time databases for certain information, how to make communication lightweight. Uh, these are very important parts, because just one or two sensors, it it's very easy to manage. But when you have 50,000 sensors, how do you manage that? That requires an entire understanding of the entire ecosystem. As you then proceed, then you have engineering managers, product designers. There are people who have, they have experience as IoT architects, cloud architects, and even database design, all, and then they are able to design an entire product. So they are a product designer. They bring all of the pieces together. They combine all the pieces together, put it into a package, and they productize it, and then they sell it. Let's say somebody who designs a smartwatch. That person who designs the system, the system on chip, the software on chip, that person would have had to have experience of all the facets. So by product designer, I don't simply mean somebody who designs the UI or UX or the visual design of the product. By product designer, I mean somebody who understands the entire end-to-end ecosystem where the product will work. That would be a product designer. Then you have IoT security. That is a very important facet as well in today's time. All these connected devices, you don't want data of, let's say, your car being shown to somebody who's not supposed to see that data. So how do you secure that? Or so IoT security is a very, very big growing field. There's a lot of demand for IoT security specialists, especially as these sensors grow in number and are getting more and more popular. IoT systems administrator, let's say there's a factory which has, 20 different IoT gateways and 500 different sensors installed. You need a systems administrator to keep a track, monitor all these systems, and ensure that everything is as per required, secure, working robustly. So these are some of the careers in IoT. I wouldn't say these are all of them. Uh, there are, other different careers, or in today's time, even everything is connected. So somebody who's working for, or working in the refrigeration business, for example, that person also needs to understand IoT, because now everyone expects that my fridge should be smart, or my air conditioner should be smart, or my vehicle should be smart, my bike should be smart, my bike should connect to my phone. That requirement has come for all different industries. So these are just some of the industries which are IoT, some of the job roles that are specific to IoT. But in today's time, everything is connected. So it is important that we keep with the times and we keep upgrading and learning ourselves and building a strong base that can be leveraged not just for 5 years down the line, but even 10, 15, 20 years down the line. So this was what IoT is all about. And I would like to now open the floor for question and answers. Uh, any questions, please, Hina? We can
Aditya,
start.
we have a couple of questions. I would read them out for you to answer.
Yep.
First question is, how do companies handle the risk of microcontroller failure in sealed IoT devices, especially when moving from Arduino-based prototypes to commercial deployment?
So typically, what happens is that most of the testing is done before the deployments are done. If you have a proof of concept or if you have a prototype, that is well and good. But let's say you are working in a high temperature environment, a factory that typically, it's a steel factory, and inside it's going to be 40, 45 degrees consistently. In the office where the engineers are developing the prototype, Arduino based prototype, or it could be any other prototype, everything might work well. But suddenly, once you go into the live environment and you realize that this is going to be 45 degrees day in, day out, is the Arduino going to perform that well or not? So, speaking about a few of the things that are done, one, you have IP based casing. There are specific casings that come that these casings will work in high temperature environments. These casings will work in waterproof scenarios, in rain environments. So all of these testings are done, they need to be done before you move into production. Otherwise, you're going to have live issues and it's going to be much more difficult to solve. So the solution to that would be to ensure that you do your testing at the prototype stage and do it as per the live environment before going live. That will ensure that you face lesser challenges once you've gone live.
Next question is from Harsh Madhnani. He's asking how AI and IoT work together. Is it possible?
Absolutely, it's possible. It's already happening. So, like I gave you the example about the air conditioner and the temperature sensor. So, of course, now, today we think that AI means LLM, but AI doesn't always mean LLM. It essentially it means intelligence that's artificial. So, when you have, let's say, hundreds of temperature sensors at or thousands of temperature sensors and pressure sensors and uh, deployed in a factory or in a warehouse, and you need a machine to take a decision what is going to be the airflow at that particular location, at that particular corner of the warehouse. That's artificial intelligence. That's no different. Then in today's time, you have very, very niche and advanced scenarios where the uh, the oil level, for example, in a machine, the amount of oil that's required to lubricate certain parts of the machine actually differs based on the temperature that's outside. So let's say you have a nice cool, it's a winter day, the temperature is low. You know that the oil is going to be denser than when the outside temperature is hot. AI can take those decisions today where it can say that use this much oil because the temperature outside is cold, or the temperature outside is really hot, so this much oil is going to be required. So that decision making that the machine can do, that the microprocessor or can do in today's time has increased with the advent of AI. So that is one of the ways where AI and IoT are working together.
Okay, next question is what are the qualifications that are needed for IoT? This is one of the important questions that our learners usually ask. So, answering this would be beneficial for them. So, your thoughts, Aditya?
So the qualifications, see, typically what for myself, I I give some importance to your degree and where you have done your bachelor's or your master's from. But I think the main qualification is how passionate are you about IoT systems. Can you answer key questions if I ask you that what are some of the challenges you face when you auto schedule some jobs on a Raspberry Pi? Or what are the challenges you look at when you get when you see RC dot when you use a RC dot local file? Can you answer this question? If you can answer these kind of questions, that means it shows passion for IoT. So I would definitely give some level of importance to the education and the background that and the course that you've done. Let's say you've done BTech in electronics, but I would give equal importance to how passionate and how skilled you are with the key technologies that are there in the field today. So both those I would give equal importance. You can definitely do a bachelor's in technology, BTech in electronics or electrical engineering, or you can do computer engineering. They are definitely going to help you. But equally important is how passionate you are and how much you've learned about niche IoT skills on your own. So both I would give equal importance.
Sure, Aditya, that was helpful. We at Future Skills Prime, we also have a lot of online courses that help students apart from their regular course of BTech and BE and computer engineering. We have courses that help them understand the basics and to do internships and to uh, do practical and to understand the hands-on experience for the project. We do all such kinds of uh, uh, courses and programs for our learners as well. Next question is from Shubham Admani. He's asking, as a software developer, is it difficult to learn or understand how this works, or is it generally the same for all software developers?
See, having a software development background is definitely going to help you. It's not going to, you need to know how to write some code to be able to code these applications together. Again, if you are really passionate about getting into IoT, then you would find the right avenues for you to learn. Like, for example, Future Skills Prime, you would take up a course, you would do the hands-on activities that are provided, and you would learn and gain your skills so that when you are asked some of those questions during an interview, like what is an rc.local file, or what does kernel mean in the Raspbian world? These kind of questions, when you're asked and you're able to answer it, it shows that you have actually taken a deep dive into the subject and you have learned it. So being a software developer is not going to hurt you in any way. It's just going to help you. It's definitely going to help you gaining some specific knowledge for IoT by taking up courses like the Future Skills Prime, going through videos, that is, and being hands-on. The most important part is being hands-on. Until and unless you've not been hands-on with it, it's not going to be of much use. You actually have to hold the Raspberry Pi in your hand and connect the wires together to be able to, start becoming confident about the entire situation.
Next question is, please give me suggestions regarding job and opportunities and how to go about searching and applying for them.
So I would say that for jobs and opportunities, it's the most important part is that one, you need to send your resume and send some of your sample projects to companies. Uh, and you need to send it to as many companies as possible so that it's not you know you don't know where it will fit and where you will click. So to find a job, that's what I would say. Have some nice sample projects, have a nice CV, send it, walk in to companies that you want to work for, walk in there and see where that takes you. It'll take you to some place good.
Uh, the time is ticking, and we have just enough time to take one question, Aditya. So, people are asking, what is the way to connect with you? If you would like to enlighten on them, and then we can take them through the Future Skills Prime platform.
Yes. Yeah. So my LinkedIn is available here. You can take this link. It's available on screen, and you can reach out to me on LinkedIn. And whatever questions you have, I would be very happy to answer them.
Sure, Aditya. Thank you so much for taking us through the session. If you would hand me over the platform, I would like to showcase to our learners where they can learn IoT on the Future Skills Find platform. If you could
Yep,
just allow me to share the screen. Yes, thank you so
perfect.
much.
Please go ahead. Thank you.
Aditya, give me a holler if my screen is visible.
Yeah, it's visible.
Sure. So, everyone, this is Future Skills Prime platform. Most of you would know about the platform as you're registered with us, but this is a new platform that we have launched this year. And you simply have to log in. And once you have logged in, you would see your dashboard. So all the courses that I do in any particular subject that I'm interested in, it will appear here. This is my dashboard and all the groups that I join with other all the groups that I join with other people and other communities. Then I have my skill passport where everything that I have done would come appear here. And we also, for example, this is the platform, and if you click on learning here, you would see all the skills. We have professional skills for people who are already in the job. We have skills for people who want to upskill themselves before they are freshers and they want to join a new company or a new organization or job or join a new job opportunity. They can go over here, emerging skills. You can see all the we have close to 12 plus emerging technology courses. All you can see is artificial intelligence, big data analytics, blockchain, 3D, and IoT, as we are speaking about, is here. You can see all the courses that are here from uh, uh, different OEMs and different providers, course providers that we have. So these are the courses that you will see on Internet of Things, and you can also explore other courses on other emerging technologies. Semiconductors, RPA, Internet of Things, etc. And let me take you through a little brief interview I'll give you about the platform. So we call ourselves as the digital talent hub of the world. We have been launched together jointly by the Ministry of Electronics and IT and NASCOM. And while you are doing these courses, these are credit associated, as in if you do your course, you invest your time here, you would get these enrolled into your academic system. This will be credited to your academic score in the year that you do it in. And a lot of courses are GOI incentivized. Let's say if a course has some money associated with it, a cost and an amount associated with it, it will be incentivized by the government and it will be routed back to your bank account. And then we have, if you are unsure about which particular emerging technology to skill yourself in, you can have we also have competency diagnostics where you can ascertain whether IoT is more your forte, or let's say semiconductor, RPA, AI, Gen AI is more of your interest. And then if you are a beginner, we have foundational course. Then if you are somebody who is newbie and has different background but want to change into another background, let's say another technology, then we have bridge courses. We have deep skilling courses for people who are very pro in their particular field. As I said, skill passport is something that we create. It will have all the database of all the skills that you have done. Once you have done these courses, you will get dual entity certification from NASCOM as well as the Government of India, Ministry of Electronics and IT. And from time to time, we do prime career fairs in various cities. Recently, we did one in Chennai where we had thousands of people join us for jobs being offered by top companies, and we do all such career fairs and recruitment drives from time to time. So be associated with the platform. As I was speaking about the certification, this is a certification that you would be holding once you complete your course from the platform. Uh, we talked about the technologies that we have. These are on your screen, the 12 emerging technologies, as well as the professional skills, effective communication, collaboration, design thinking, product management, all of these courses that you want to learn, upskill in as a professional or as somebody who is a fresher and wants to join the job world. Also, I would like to bring I'm sorry for this. Also, I would like to bring to your attention that this is on the right hand side of your screen. You see Future Skills Prime QR code. If you scan this QR code on your mobile, you would directly be led to the platform. From there, you can easily sign up for the platform. As I mentioned, this is the National Credit Framework. You get all the credits in your academic system. Once you do any of these courses, you can talk to your professors, you can talk to your administrators, and these will be added to your credit. This is again the Future Skills Prime platform. Do follow us for more such webinars. We do various tech pathshala sessions and webinars, prime career mantra sessions, where we deep dive into various technologies, the career paths, the skills needed, how you can go about looking for job opportunities, all such details that as a newbie or as a new fresher you want to understand and you want to have a better sense of. So these are the platforms. Do follow us. We keep doing various contests as well. Currently we are running summer of skilling contest, wherein you just have to post a video and you will get great goodies from us. It has a sustainable bag, it has a zipper, it has different goodie bag that you will get once you participate in the contest. And we do keep doing such contests from time to time. So just follow these platforms. And yes, so this was about the session. Uh, Thank you everyone for being a part of this session till the very last, till the very end. And Aditya, thank you so much for joining in and for enlightening us about the subject. I, as a layman, understood the concept of IoT in a way better, more sense than I used to before. And also, since you also mentioned that understanding the market and the technological landscape is as important as understanding the practical hands-on experience about the subject. It's very crucial, and we also keep talking about it from time to time. Thank you so much for being part of this session, and we will keep inviting you for more further sessions in the future. Thank you so much.
Thank you. Thank you very much.
All right. Thank you. Bye bye.
Thank you. Bye.